You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech and Finding Genius podcast. I have Professor Arto Annila. He's at the University of Helsinki. He's the author of a book called Back to Reality. We're going to be talking about some big issues. What is time? What is space? What makes it matter? And what is life? What is consciousness? Simple stuff that everyone obviously knows the answer to already. Just kidding. But Arto, thanks for coming.
Oh, thank you, Richard.
Yeah, so it's rare, I found, that people even want to think about some of these big issues, but then again, people have thought about them, I'm sure, since the beginning of mankind. What prompted you to be interested in these big questions?
Well, some 20 years ago, as a newly appointed professor of biophysics, I asked myself, how come the theory of evolution, Darwin's Tenet, evolution by natural selection, has not been written as a theory of physics? After all, physics endeavors to explain everything with mathematical rigor, but there is no equation for evolution. This state of affairs is a paradox because evolution is motion and physics is all about motions, particles bouncing on one another, reacting with one another. The whole universe is in motion, yet there is no theory in physics for evolutionary motion. So that question really took me along this long voyage.
Yeah, when I've heard people speak about evolution, they just say, oh, it's just evolution, and they don't define it at all, and they don't define what it is, how it works. Anything that's inexplicable is just kind of put in that category, in that nameless thing.
Yeah, of course, I'm not the first one to look for the theory of evolution in terms of physics. Soon after Darwin's masterwork on the origin of species came out, Ludwig Boltzmann, an Austrian physicist at the end of the 19th century, aimed to formulate the theory of evolution based on thermodynamics. He thought that not only animate evolve, but all kinds of changes follow the same principle. Boltzmann based his reasoning on the fact that data look the same, irrespectively what we look at. Namely, the spread of species looks the same as diffusion of gas. The growth of a population looks the same as the growth of an economy. The decline of vegetation looks the same as the erosion of soil, and so on. Everywhere we see the same pattern. So what I have been doing is not that unique. It may be unique at our times that have specialized to look into detail rather than looking at the whole.
Well, what are some of the details then that you're looking at? What kind of specific questions are you trying to answer here? Because all of them are huge.
Well, of course, the devil is in the details, as they say. The quantitative data of physics is the one where one can test this sort of ideas to see whether they really hold. Whereas many of the complex systems, like those of the living systems, are hard to test with that kind of rigor. So that kind of understanding pointed towards looking the basics of evolution. What is the minimal change that one should identify as the elementary step of evolution? So that is the clue for a physicist to try to figure out what is the equation of evolution.
Well, how would you approach that? What would be candidates for the smallest element that constitutes evolution?
Yeah, one of the clues is that I used that I explained in the book is that when I'm standing under the starry sky, the cold starry sky, I'm losing heat, but the loss of heat does not take place all of a sudden. It takes time. That is to say, the heat, the photons, the quanta of light that I'm losing to the cold sky are not only carrying energy, but they also carry time. That is a trivial observation, but nevertheless, it's really crucial to understand that the quanta of light that are escaping as heat are not only carrying the heat, but they also carry the time. In this way, the essence.
How do they carry time? Is that because an observer can see the redshift from a far enough distance, or
it's far more simpler. I mean, the photon carries energy over its period of time. So the time is as concrete attribute of the photon as energy. So energy and time go hand in hand. Of course, we are very accustomed to the idea that photons carry heat, but we are less accustomed to the idea that energy and time are on the same footing. They are both properties of the quantum of light. And that makes the concept of time very concrete, tangible.
Well, wait a minute. Does a photon decay? Does its energy decay over time, and that's why it has a time element? Or does it never decay, and how does it have a time element? I don't understand. Sorry.
Let me put it this way. The photon has a wavelength, and a wavelength divided by the speed of light gives you time. That's what we call the period of. The photons have very different kinds of photons, that is to say, different colors have different wavelengths, and they have different times. But nonetheless, all photons carry time. And that's the whole point of making time as a concrete concept rather than being an abstract notion. And that is a key to the understanding what evolution, changes, development is all about.
Okay, so how would you use the fact that photons have time? What would you do with that?
Well, then it's possible to figure out the equation of motion, that is to say, equation for evolution, because all those motions are nothing but the motions of the light quant. And that is, of course, the idea that the Boltzmann had in the beginning, that everything comprises of the same basic elements, which he used to think are the atom. And that is, in a way, the prerequisite of his universal theory, that everything is made of the same stuff. And then it is only up to us now to recognize, now that we know that the atom divides into the nucleus and the electron, that it's not the atom, but it's the photon that is the basic element. And then we can take the Boltzmann's recipe and formulate the theory as it should be done to describe all kinds of changes.
Well, so you're saying that evolution is just a change in the state of one particle? Or, I mean, again, how are you even defining it to start to get a wrangle on it?
Yeah. Any kind of change and a sequence of changes is what we call evolution. There is nothing, let's say, intrinsic in biologic that should be granted for the name of evolution. But everything else, the whole universe is expanding, that is to say, evolve. When we look at the data, irrespective whether it comes from animate or inanimate world, they look the same. That is to say, everywhere we see sigmoidal growth curves, everywhere we see skewed distribution. And if we plot that data on logarithmic scale, everywhere we see straight lines, that is to say, power law. So if we did not know where the data comes from, we would not know whether it's describing animate or inanimate changes, that is to say, evolution. So this is purely an artificial construction or a contrived idea that evolution should be limited to animate. Of course, this is what Boltzmann had in mind, that evolution of any kind can be presented with one and the same equation.
So there's nothing different or special to you about life versus non-life. You think they both
That's right. Yeah.
move in the same way?
Yeah. Let's say that it's not really of my opinion or thought. It's the prerequisite postulate or axiom, whatever you want to call it. That is the way how things are looked upon when everything is considered to comprise of photon. I mean, it's the kind of a viewpoint that I have and see how the world looks from that viewpoint and see whether it makes sense of the data, whether it makes sense of the observation. And that's the whole idea behind the book.
Well, then, I mean, there's been no example that I know of a biogenesis of life from non-life. Why is that? And how would that, is that question, it sounds like the question is not even worth answering in this scheme, but how do you answer it?
Yeah, sure. I mean, now you say that you use the term life as if you were able to define what life. That's a very critical issue, because if we can't find an unambiguous definition, then there is not really a thing to explain. That is to say, how life originates. I could equally well claim that never happened. That is to say, we have just a continuum of from what we call inanimate to animate. And it's only that what we call living has evolved over times to that extreme sophistication that we no longer relate to its very trivial beginning. But once you have the equation of evolution at hand, you can analyze it and realize that chemical processes follow the same kind of sigmoidal growth curves as more complex systems like plants and animals. So there's really no distinctive attribute that we could assign with life.
I don't know. I mean, again, no one is, if you want to say it's trivial life, early life, the beginning of it, I mean, if it's so trivial, then people have not been able to recreate it in any sense at all, no matter how simple. Whether plant, animal, bacteria, whatever, nothing.
Yes.
A virus, no one's been able to create one.
Well, I should say that it's possible to assemble living viral particles from their constituents in a test tube. You put the right constituents in the test tube, and they will assemble themselves to infect viral particles. Of course, I'm not saying that it's the same thing as creating the virus from the basic molecules in the kind of as Ray Miller experiment. I'm not referring into that. I'm not, in a way, denying the same, but I'm just saying that the principle is the same.
Well, I don't know. If the principle is the same, then I think people will be able to understand it, characterize it, and do it themselves, but they're unable to. So there's some missing element there.
Well,
no one knows what it is.
Well, it may seem like that. Well, we must remember that the scale, both in time as well as in these material constants that we have experienced here on Earth, is immense compared to those little things that we can possibly accomplish testing.
That's another thing. That's another place where scientists seem to just say, "Oh, it just takes millions of years. That's why we haven't observed it." But why? Why would it take millions of years? And why wouldn't we? I mean, if things happen on some kind of regular basis, why wouldn't we observe them during our lifetime? I mean, why would things take millions of years? Is there a half-life to non-living to living? I mean, it doesn't seem to be. It doesn't make sense when, again, when Darwinists say, "Oh, it just takes millions of years."
Well, it's
easy to say, but it's completely unprovable.
Yeah, it's very true what you say, that the time, what it takes, is no argument, because every system aims to gain balance with its surrounding. This planet is green. That is, we have a vegetation because matter on this planet aimed to gain balance with the high energy sunshine. So that explains why the life emerged on this planet. There was a driving. Of course, we can set various kind of driving forces in the test to get what we want. And that's what we do by setting ingredients there and providing sparks or whatever photochemical driving force to make things happen. And they truly happened. Well, we have hard time to create such a condition, such a surroundings that would lead to sophistications such as bacteria.
So if you say something happens over millions of years, that would mean that I can break it down into something happening over days or even a few years.
Yeah.
Something must be if something takes 1,000,000 years to happen, okay, well, some part of it has to be happening in 10 years.
Yes, absolutely.
You know, it has to be some finite amount of change.
Yes.
So I don't even know if has that been observed? I don't know if that's been observed. It's to just say that, not even you, but just for someone to say that, something happens over, millions of years.
Yeah.
Again, something has to be observed during the period in which we observe.
Yes, certainly we observe chemical reactions to advance in the directions where the surroundings force these reactions to take place. Likewise, we see all kinds of processes going towards what the environment commands place. So if we were just able to create a condition that would drive these processes towards that kind of sophistication that we call life in a very short time, it should happen. But we have no means to make that kind of condition.
It's easy for us to kill things, to take them from life to non-life.
Yeah.
It seems completely impossible to go the other direction.
Yeah, I wouldn't
make any
say
steps in the other direction.
Yeah, I wouldn't say it's completely impossible. We can create complex organic molecules, and like I said, from these complex molecules, we can assemble infective viral particles. I think that these are impressive signs that there is nothing mysterious about life. It follows the same principle as any other.
So what's your role in this? Do you want to be one of the people that figures out, how to create life from non-life, or find one more piece of the puzzle along this continuum, or what do you want your role to be?
Well, I don't know if it is something that I desire personal. I think that my role is to inform that physics can adequately describe processes that we call living by the same equation as that account for those things that we call non-living. And to back up this claim is that the data looks the same. We can't tell a difference. It's us who have set the labels and scales on these graphs, but we would not tell a difference from the data alone, whether it comes from the inanimate or animate world. And this theory is what I see is important to bring forward. And that theory is based on the postulate that everything comprises of the same basic elements, just as Boltzmann already laid out. And that basic element is the photon. And then we have a comprehensive theory, which we can test against quantitative data. And that's what I see as my role, to bring this knowledge forward.
So is there some experimentation that you're doing, or you just want people to accept that, okay, if you look at it in a data sense, life and non-life, there is no division. So start from that thought process and go from there.
Yeah.
Again, what are you specifically doing to make an intervention in this area?
Well, there are all kinds of experiments that have been tested or tried out. It's a matter of how the data should be understood. It's not about how it should be modeled, mimicked, or simulated. It's about understanding the driving forces. Why does the data look like? Why is it that the growth curve is a sigmoid form? Why is it that these distributions are skewed? Why is it that all data look the same? That is what I think is more important to ask and answer than to just to reproduce the data by some modeling.
I don't know if that's answerable. There's one way is to find the commonalities between life and non-life.
Yes.
Another way is to look and say, are there some non-commonality?
Right.
Are there things that only happen in living systems?
Right.
For instance, the use of quantum effects. There's a new field of quantum biology, whereby in photosynthesis, it seems to be observed that the plants are using quantum effects, and in birds, and in which is unbelievable. Is there any example of a macroscopic, non-living system that uses quantum effects.
Yeah. Well, I say that what I'm talking about is all, but is just quantum. I mean, if I describe everything with as being quanta of light, then the whole theory is about quanta, without making any difference between whether it's a microscopic or macroscopic. It's everything is quanta, and therefore it behaves the same way at all scales.
Well, I mean, I don't know. Does it? There's there's again a regime where quantum effects seem to dominate, and then there's more of a macroscopic regime where they don't.
Well, it's very, very true that when you have a lot of quanta, things seems to be more like continuum. Like we know that water is composed of molecules, but when we had it in a bathtub or something, it looks like continuum. So I'm not denying this sort of a macroscopic versus microscopic difference, but I'm just saying that when everything is composed of quanta, then everything can be treated in the same way, understood in the same way, and described by the same equation.
I mean, it seems like a tough task. We can't even describe, we don't even really know, I guess because of Heisenberg uncertainty, like what an electron is composed of, or what is it? How does it work? Why does it take on energy in quantized amounts? Like even what does an electron look like in relation to when it's captive to an atom? We have a wave function, but we really don't have very much information on it, it seems.
Yeah, that's very sharp understanding that modern physics is vague in ontology when it resorts to mathematical concepts, just like a wave. What is it? Can I eat it or beat it? Is an ontological question, and modern physics is very silent about the ontology. It just uses these mathematical models like quantum mechanics that fits it, but doesn't really explain, as you say, how the electron looks like. But if you consider that everything is composed of quanta of light, then you're bound to come up with an answer. How does the electron look like when it is being made of quanta?
Yeah, I mean, I don't even know if it's, again, mathematically, it looks like, for instance, the electron is moving, but is it pulsating in and out of existence? I mean, what's the next level beyond, an electron cloud? What's the next level of representation, even for something like that, in a hydrogen atom?
Yeah.
It's just, it just seems unknowable. It seems like so unbelievably complicated that I don't know. I don't even know how you'd even approach, like, have you come up with thought experiments? Like, where are you taking this?
Right. It really seems obtruse to us that we can't penetrate into these mathematical concepts. And therefore, what I've been promoting is a very concrete, tangible worldview where I describe the electron being composed of the light quanta, just as the vacuum surrounding the electron, where we see the manifestations of the electron like the electromagnetic field. Then we have much more concrete view of these elementary particles in the same way as we understand chemical compounds being composed of atoms. In the same way we can understand how the electron looks like when it is composed of quanta of light. And conversely, how does the vacuum look like when it is composed of quanta of light? That's what I find fascinating.
Yeah, I mean, what is the, it's weird, like, what is the vacuum? I mean, if there's, even within an atom, the space, the area in between the nucleus and, the electrons surrounding the nucleus seems to be vast. So is that vacuum?
Yeah, indeed, it seems like a perplexing question. What is it between the nucleus and the surrounding electrons? And of course, the physics textbook tells us that there's a Coulomb field, which is composed of photons. So we know that there are indeed photons mediating the electrodynamic interactions between the nucleus and the electron. And therefore, it is reasonable, that is to say, empirically and logically sensible to think that the vacuum, the void, the empty space is in fact full of photons. Of course, the issue is here, how could it possibly be composed of light because it's transparent. And this sort of question is surprisingly easy to understand if you realize that the photon is a wavelength. And if you combine two waves so that the highs and downs go the opposite each other, that is to say that waves cancel each other like two waves of water can cancel out each other and form a flat surface. So if you have two photons in the opposite phases, that is to say, canceling each other, then you don't see light, but nonetheless, the photons are there. That's what the vacuum is in terms of light.
Oh,
can you imagine that view where you have two waves so that they cancel each other and then there's a flat surface, but still the water is there?
Well, it never ends, though. What are the waves propagating? Waves in water are propagating through those,
yeah, the waves
molecules
of
of the water
are
itself.
water.
But
yeah,
right, but in a vacuum, what are two photons propagating through? What's around them? What are they sitting in? True vacuum?
The photons are not sitting in the vacuums. They are making the vacuum. They constitute the vacuum. The vacuum is not a medium for the photon, but the vacuum is made of. And once in a while, we see not paired photon, but single photon. And that's what we see as light. Of course, these are the very questions that Maxwell and Faraday thought in the 19th century. They were wondering what the vacuum is all about, because you can see effects surrounding charges and mass like electromagnetic fields and gravitational field that seem to be around the body, that is to say, in the vacuum. So they wondered what kind of substance is this vacuum? But at those days, they did not have the concept of quantum of light, so they couldn't quite figure it out what it is made of.
Well, I don't know how to make any headway with this stuff. That's why guys like you are working on it. But so, what's any breakthroughs in your work that you feel are coming, that you're close to? What do you expect may come from your work in the next couple of years?
Well, I wouldn't be expecting that much. It's more like what I've been doing with my book is to summarize my research since over 1 decade or a little bit more now. I'm not really expecting that much, because what I have this worldview where everything is made of photons, and look at the things from that way, from the elementary particles to the expansion of the cosmos, from molecules to the biosphere, or from a bargain to the world trade. So I look at the things from this perspective that everything is only these quanta, and every motion, every development, every evolution is flows of quanta. And I look at the world from this perspective, and it makes sense to me. It allows me to tackle these kind of questions that we now discussed. What is life? What's its origin? Of course, these answers, what I provide from this perspective, may not meet our expectations. We just saw that they seem to be somehow not answering the question that we were after. We were after the question, how did life originate? And I replied, there is no such a thing that could be called unambiguously as life, and therefore its origin is a meaningless. But there are other questions that are more amenable to analysis and understanding. Like what I'm saying is that when we understand what the vacuum is all about, then we also understand these sort of hypotheses that we called dark energy and dark matter. We find that they're obsolete. They're results of interpreting the data with a theory that does not hold substance. And therefore, we end up into this kind of ad hoc assumption of there being dark matter or dark energy. So these sort of issues can be tackled when everything is understood to be comprised of quantum.
Well, very good. Well, Arto, what's the best way for people to even start to get a handle on this and get a grasp and learn some of the underlying concepts they would need to understand what you're doing?
Well, of course, you can Google to my homepage, and there are some papers to read or citations and that sort of things. I have my book published just a month ago. However, in Finnish, the translation is being worked on, and I hope that the translator will complete the job sometimes early next year, and then it's easier for everyone to get hold of this idea. Well, I should say that I'm not advocating or promoting this worldview. I'm just making it available for to be challenged, debated, and discussed. That's what the science is all about: to test and question and to see how to make sense of reality.
Yeah, well, it's a long journey ahead. But Arto, at least you're thinking about this, which is good. Very few people do.
Thanks.
So, yeah, I appreciate you coming on the podcast.
Okay, thank you very much.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.